A ResUNet is a hybrid architecture that combines the ideas of ResNet and UNet for image segmentation tasks. It leverages the strength of ResNet's residual connections and UNet architecture that is particularly good at capturing context and enabling precise localization. The network takes an image as an input and passes it through a successive layers. We have the downsampling path, a convolutional layer 3x3, and a ReLU function. This applies filters to the image to create feature maps, capturing various features such as edges, textures, and more. Each is followed by a ReLU activation function to introduce nonlinearity. The mask pooling layers, indicated as red arrow, reduces the spatial dimensions of the feature maps, effectively downsampling the image and helping the network to capture larger context. A convolutional layer, followed by a mask pool, and another convolutional layer, followed by a mask pool, which goes in that order. This part of the network processes the most abstract representation of the input data, and it's typically where the deepest residual connections are made. The up convolutional layers 2x2 increase the spatial dimensions of the feature maps, effectively upsampling the images, and followed by a concatenation with the corresponding feature map from the downsampling path, known as copy and crop. The copy and crop operation merge the upsampled feature map with a corresponding feature map from the downsampling path, providing a high resolution features for the upsampled images. The final layer of the network outputs a segmented map that classifies each pixel of the input image, using a 1x1 convolution to map the deep feature representation to the desired number of classes.